This video will go through a bearing application problem that requires the use of the cosine and sine rules. First, it's important to draw a somewhat accurate large diagram based on the given information. So let's start with the fact that an aircraft starts at its base, goes 200 kilometers on a bearing of 162 degrees. So I'm going to draw that first. So I have my compass cross here. And if you remember, bearings always start from north and swing clockwise. So if I were to do this half circle, that would be 180 degrees. So I want to go a little shy of that to 162 degrees. So I'm going to draw my segment coming out about here from this center point. Okay, so I've drawn a 162 degree angle, and then from there I've gone out 200 kilometers. And I'm also representing that this small angle in here would be 18 degrees because 162 plus 18 gives me 180 degrees. Now down here I want to draw in another compass cross and proceed with the next step, which is that the plane goes 350 kilometers on a bearing of 260 degrees. So from here I have my cross, and again to do the bearing of 260 degrees, I start from the north, I swing clockwise, and 3/4 of the way around would be 270 degrees. So I want to go 10 degrees shy of that. And then I draw out from the center where my plane was at the end of the 200 kilometers. I draw out from there 350 kilometers. By labeling these various angles, I can also reason out that this angle here must be 72 degrees because this forms a right angle, and if this is 18, then the rest would be 72. So this large angle in here would be 72 degrees plus this 10 degrees for 82 degrees. I'm being asked to calculate the length and bearing of the return journey. So here's the return journey, and to find the length, we already have everything that we need. Since we know these two sides of this triangle and the included angle, I can use the cosine rule to find this side over here. So I've labeled that side as x, representing my return journey of this aircraft. And now I will substitute in the values for the cosine rule to find x. So here's my work for the cosine rule. And when I do out this calculation and I take the square root, I end up with 378.17 kilometers. So that is the length of the return journey. Now to find the bearing of the return journey, I want to draw in one of my compass crosses here because I'm going to need to measure. So the bearing of the return journey means I want to know on what angle do I go to get back to the base. So I need to know the angle from the north swinging to this length that we just found. So I'm going to put in my compass cross. In addition to this cross, I've labeled that this tiny angle here is 10 degrees. And I know that because of this angle over here, which is 10 degrees. And I have alternate interior angles because I have two parallel lines and my transversal here. I've also labeled that this angle, which is one of the angles of the triangle, is theta. So if I find this angle theta, and I know this is 10 degrees, then I can subtract those two angles from 90 and I will have my bearing. So my next step is going to be to find this angle in the triangle by using the law of sines, because I know a pair. I have this 82 degrees and I found x, and so I can use inverse sine to find this angle here. So here's my sine rule set up, the proportion that I set up, the sine of theta, which is here over 200 degrees equals the sine of 82 over x, which we found was 378.17. Solving that, I got that sine of theta is equal to 0.523 and so on my calculator. I'm going to hold that whole answer on my calculator. And then when I do inverse sine, I get that theta equals 31.58 degrees. So I now know that this angle in my triangle is 31.58 degrees. Remember, the bearing that I'm looking for is this angle over here. So now from 90 degrees, I'm going to take away 31.58 degrees and 10 degrees, and I will have this remaining angle, which is my bearing. So I've calculated that the bearing is 48.42 degrees, And again, I did that by doing the 90 degrees, which is this full quarter of my circle, minus the angle within the triangle, and minus 10 degrees. I hope this video was helpful for working with bearings, and I will talk to you soon.